Hello and welcome to our next installment of the eVTOL Writers Group interviews. Today we have a great interview with a company that you may or may not have heard of, and we're trying to get them some information out on their products and services. So let me just first start with some logistics here. So in your GoToWebinar dashboard, you will see a questions box. So at the end of the session, we will have the opportunity for you to ask questions as part of this interview process. So please use that questions box to ask your questions of both of our presenters today. With that, I'm just going to go ahead and get started. I'm going to introduce our moderator for today, who is Dave Clark. Dave is a graduate of San Jose State University and UCLA, and he's a regular contributor to the Robb Report, Atlantic, and some other periodicals like the San Jose Magazine and Mercury News. He is the managing editor of the San Jose Magazine and the editor-in-chief of Oracle's Profit Magazine, and more importantly, he is the editor-in-chief of Aerocar Journal. So with that, Dave, I'll let you take it away.
Thanks. Good morning. Thank you, Jim. Thanks to Mike, who I know is in the background working, and to the Vertical Flight Society for arranging this for us. I've been doing some background on CS to learn a little bit about what they do. And I wanted to introduce Jerome Casteret, who is, what do I do with your title? VP of Communications and Systems, different note, and Matthew Tkac, who's the President and Chief Engineer of CS Group. They are based in Hartford, Connecticut, and they are software developers in the aviation and avionics, and I think it's a lot of automotive spaces. Yep. So they've kind of given us their time today, and I think we'll just let them tell us what CS Group does and what it's all about, and put your questions in as you think of them. They'll show up, as Jim said, in a little box, and I'll present those after they're done speaking. I'll be here, but I will be turning my camera off now.
Thank you, Dave, and thank you for the opportunity for CS to show our expertise and value in the field of certification related to safety critical embedded software. So if you jump to the agenda, please. We will go through a quick overview of CS, who we are, what we do, and then we will jump in the meat of this presentation. What is the IO 178C norm? Where is it applied in compliance with the certification processes? And we will go through as well the main roadblocks of certification based on our past experience, and we will go through the, I would say, the best practices related to, in order to avoid these blocks and to not compromise the quality of the software, and to respect cost, budget envelopes, and timelines. So if we go to the next slide on the CS overview, CS is an international group. The mother company is in France. We have a North America footprint. Next slide, please. We have a North American footprint. We are based in Montreal, Quebec, and East Hartford, Connecticut. The core business of the company is to provide engineering services related to mission critical and safety critical systems and softwares. I would say the mission of CS is to support OEMs, tier 1, tier 2 suppliers in the burden of the certification. And most importantly, to reduce their cost of the software development and the software testing. You go to the next slide. So you see here that predominantly we are in the aerospace and defense and automotive sectors. We are running right now multiple projects for commercial aviation, for US military products as well. We have two facets of the company are first, providing services. So we support clients in software development, software testing, certification. But over the past few years, we invested in products, mostly software tools, automated tools, in order to enhance the quality of our services and the performance of our services. And we will have some headlines behind this presentation. So let's go in the norm itself. So if you go next slide. So why the norm? The norm was created as a response to the growing footprint of software in aircraft systems. So this is a norm which is approved and recognized by all the regulatory authorities like the FAA, Transport Canada, EASA. The norm is built on two main principles. First, that the software behaves and meets the system intent. Very important, no more, no less. And the second principle is related to the software failure. What is the impact of the failure on the system itself? We'll go through this aspect in the next slides. Next slide, please. A bit of history. The main dates, 1982, the first version of the norm that was born. 1992, the version B of the norm was introduced by the LTCA and the EuroCAE, and the last version was born in 2011, especially in response to the new innovative techniques and tools that is used today to develop and test the software. And Matt will have a few words regarding to the supplements that were created on besides this norm. Next slide, please. I will go quick on this slide, just again to highlight the fact that the impact of the software failure safety is really the foundation of this norm. I want to highlight that the security aspects now are becoming more and more a topic for aircraft systems. My software can be hacked. My software can be controlled by an outsider. So outside of the DO-178, the DO-326 was a new norm that was born to address these specific topics. And definitely that will be part of the next presentation that we will do for you guys. To go to the next slide, please. One word on the failure modes and failure conditions. The norm defines different guidelines depending on the severity and criticity of the system failure in case the software is not behaving properly. So you imagine that in an aircraft, an entertainment system has absolutely no impact on the safety of people. On the contrary, a flap system or an engine control can have definitely an impact, and the life of people is at stake if the system is not working properly because of the software. So the norm defined what we call the design assurance level, A to E, depending on this criticity. E for the lowest type of impact, A for the most critical impact. So we will see in the next slide with Matt on how the norm define the different processes and what are the next certification steps that we need to comply with for every safety critical embedded software. Matt?
Thank you, Jerome. Next slide, please. So this slide shows a typical VCycle that we're familiar with software development and software testing. And basically, coming down on the left side, we start with system requirements. What's the system supposed to do? and further decompose those requirements down to the point at which the software can be designed and built. And then we start testing that on the right-hand side, going back up on a piece part basis until we get back to full system integration testing. So whether it's agile or waterfall or whatever the design methodology that people are using, it's still very much the same as this VCycle, that we want to be able to specify everything, build it, and then test everything according to the requirements that it has for that specific unit, software unit, or collection of software units. Next slide, please. So in the vein of DO 178, plans are critical factors. Basically, we need to document what we're going to do and how we're going to do it to design, develop, test, and provide configuration management for the given software applications. So in there, you can see that we have the PSAC, the Plan for Software Aspects of Certification, and that's kind of the governing document that references the rest of the development plan, the verification plan, the configuration management plan, software quality assurance, as well as program management plans. So it all comes together through a governing factor. And again, these plans are really on say what you're going to do, say how you're going to do it, and say when you're going to do those items. Next slide. So when we look at what these plans really have relative to the different aspects. For the system, we want to have an overview of the system, how requirements get allocated to software, and the relationship between all the software packages within there, the OS, the application, you know, the interface software between OS and AS, drivers, what have you. We want to talk about processes that we're going to follow and tools that we're going to use within it, as well as artifact control. So what comes out of these tools and these processes needs to be governed and documented. Planification, we want to talk about timeframes and versions and goals of certification. So we understand how the software lifecycle is going to move through its development all the way out to revenue service and beyond, as well as organization. What does the organization look like? How does the organization work together to get the software developed properly? And then, of course, quality assurance and control across the entire project. How do we ensure that we're doing the right stuff, we are following our process, and we are meeting what we said we were doing in the plans? And all these come together really to, you know, as that top bullet says, is really to be the communication to certification authorities, so that they know exactly how this software is being built, designed, developed, and built, as well as tested, configuration managed, and reviewed, so that there's no questions as to how we need to go forward. Next slide. When we look at the software development plan, it really comes up with some global objectives for development, that we want to create software requirements, the HLRs, high-level requirements of what the system is supposed to do. Then we get into design requirements, and those are the LORs, the low-level requirements. And those can be derived from the HLRs as well as specific needs from whatever the platform is that it's running on, processor-specific information, memory-specific information, what have you. Software coding, the objectives is really to get source code that's developed from the LOR. We have a set of code that meets the requirements. And then integration. As you're aware that a lot of software is developed within modules or packages, and those packages need to be integrated to show that everything is working accordingly. So we put all those packages together to show that it's meeting requirements. Next slide, please. We also want traceability. So traceability starts at the very high level, the SLR, so the system level requirements, and then it flows down to the high level requirements, low level requirements, and source code. And we want to see, ideally, 100%. We would love to see that on the flow down, that every system requirement is being addressed by an HLR, that HLR is being addressed by an LLR, and then those LLRs are developed by source code. on the way back up, so there's downward traceability and then back upwards traceability, that we could have more LLRs than HLRs. So we have some derived requirements, as well as having more HLRs than SLRs. Again, those derived requirements come in to deal with specific instances, whether it's hardware related or whether the company needs some specifics or does some specific things associated with it. But we want to make sure that we can enable verification of the complete requirement at the highest level. We want to give visibility to those derived requirements, give visibility to architectural decisions made during the process, and enable verification at those various levels so that we can show that the software is meeting all of its requirements, as Jerome mentioned earlier. Next slide. The software verification plan. So again, the software verification plan deals with development reviews and testing. So we want to look at the requirements review and compliance. We want to see that we're compliant with system requirements, we conform to standards, accurate and consistent, compatible with the target computer, verifiable, as well as traceable. We want to ensure that traceability, again, that we talked about earlier. The software design review, we want to see that we're compliant with the high-level requirements. We want to check the accuracy and consistency. Again, compatibility with the target computer. Make sure it's verifiable. Make sure it's conforming to the standards and it's traceable. And we also want to make sure that we look for the partitioning integrity to ensure that those boundaries are in place and are enforced. With the coding review, we want to ensure that we're compliant with the low-level requirements, that we're compliant with the architecture, it is verifiable, and again, conforming to the standards and is traceable. And then finally, at the integration review, the output's complete and correct through the examination of compiling, linking, and loading the data and memory mapping. So we want to make sure that the software works in its entirety as a complete package when it gets to the target processor or target boards. Next slide. So software testing, right? The testing itself, we want to do software requirements-based testing, and that will further drive low-level tests, software integration tests, hardware and software integration testing. So, and then it just feeds back at itself through the life cycle until we get complete with the end of testing. We want to make sure that we comply with the high-level and low-level requirements, that we're compatible with the target computer again, as well as that the system's robust and can deal with not only normal inputs, but abnormal inputs to ensure that we meet the safety requirements as Jerome illustrated earlier. Next slide, please. So DO-178 is really guidelines for certification. So it provides basically how you need to do your certification processes, your qualification processes in order to meet the safety aspects of critical embedded systems. But there are lots of ancillary issues that are supported, and to address those, RTCA has supplemental information that supports it as well. Next slide, please. So specifically with DO-178C, there was 3 supplements that were created. In addition, there is a tool qualification one. So DO-330 is tool qualification, and that talks about how the tools need to be qualified in order to be in the process of qualifying and certifying your software, and what the criticality and aspects that are needed to ensure that that happens. DO-331 is model-based development and verification. So everybody is getting familiar with model-based systems engineering, model-based design and software development. And so RTCA had to come up with a methodology that supports model-based development and verification, yet still meets the guidelines associated with DO-178 about testing at the appropriate levels, and independence. DO-332 is object-oriented and related techniques. and DO 333 is formal methods. So those supply additional methodologies that can be employed to help with the certification process. Next slide. So in the past, and unfortunately I'm part of the past, I do remember the good old days of everything was done manually. And so we didn't really worry about tool qualification because there was always an engineer in the loop reviewing information as it came forward. Now, there's a lot of automated tools that are doing the job, and potentially they're more reliable than humans. They tend to be able to work large quantities of data very quickly. And more activities are being done by tools. Source code generation, test case generators, test procedure generators, review by dissimilar coding, and automated analysis relative to timing, stack, and memory usage. So because all of this automation comes in, again, the DO 330 needed to be created to provide suitable evidence that those tools are available and can be used to take credit through the certification process. So we needed to just lock down how those tools are done. Next slide. So what is tool qualification? It's a process to gain certification credit for an automated tool replacing an identified objective in DO 178. When do you need the qualification? The process of DO 178Cs are covered or partially covered by the use of that software tool. So it needs to be qualified before it gets actually used in the qualification or certification. We need to define guidance to development and validation of a tool. Basically, it needs to go through at a very high level a similar kind of process as the actual software we're developing for embedded systems. And qualification can be done with COTS tools or custom-made tools. It doesn't have to be a tool that comes from the vendor. It can be tools that you develop in-house to support that effort. Next slide. So DO 331 is model-based development, and the aim is to use precise and appropriate languages to unambiguous record requirements, basically to create models and be able to let the engineers use those models for the development purpose, for the honing of their system, to treat those models as the requirements, and then further derive design models for the low-level requirements that would implement those requirements. So there are tools on the marketplace, SCADE, MATLAB, and Simulink are available that do a very nice job of doing this. There are other tools, of course, but those seem to be the two bigger players that we see more of. And again, the big thing with model-based development is separation of high-level requirements and low-level requirement models. We want specification models and then design models that are independently generated from those specification models so that there is that separation of requirements and design, just like in the VCycle. Next slide, please. So the things that DO 331 do is it enables testing in a model environment. We can use the models to actually develop some of this testing and ensure that the system is operating the way it's supposed to. We can use simulation environments so that we can look at model coverage analysis to see that we're covering everything we're supposed to, and to be able to qualify the simulation environment as being the same as the target environment. So we've got to be able to ensure that what we do in the simulation really does match what happens in the real world. There are several tools that are available to support this, QTE for SCADE and SLDV for Simulink, that really do a lot of the automation as well as the test case generation and execution to ensure that we're meeting those objectives. And last but not least, that the D178C objectives are applicable and completed within this specific objectives of DO 331, so that those two documents really go hand in hand in how we would certify software. Next slide, please. So the certification steps, I think at this point, I'll turn it over to Jerome. Is this the slide? So the next, oh, go ahead.
Next slide, please. Quick reminder regarding the software certification. Again, the whole idea here is to convince the regulatory authorities like FAA, Transport Canada, EASA, to convince them that the development, testing, and all the processes that was mentioned by Matt were fully covered and comply with the DO-178. So I don't emphasize enough on the fact that having a DER and a DAA at the beginning of the process is very important in order to ensure a smooth certification for your embedded software. You go to the next slide. In terms of steps, for the people who don't know, we have to, and this is part of the norm, we have to comply with what we call the stage of involvement, SY 1 to 4. So this is the main milestones defined in order to convince the authorities that you comply with the norm. SY1 will ensure that you have already the tools and methods in place. SY2 will ensure that your development meet all the criteria of the norm, depending on the design level of assurance that you have. SY3 will be the verification piece, just to verify again that your testing comply with the norm. And then the SY4 would be the last step, defining and with the last paperwork to be provided in order to reach the timestamp from the certification authorities. Just want to mention that there are some different kind of certifications. So you may have a subsystem certification. It can be a system certification, and then usually before entry into service, you have as well a specific certification that can be usually a Delta certification versus the previous one. So now, if you jump on the next slide, please. Next slide. So I just want to give you a little bit based on our past experience again, what are the main roadblocks / mistakes that we saw during former certifications with some clients. The first typical issue is you don't plan for this certification. So basically, a lot of clients decided to, because they are in a prototype phase or in a concept phase, decided to develop the software ad hoc, and then they come back to people like CS and mention, oh, we have the code, so what it takes to certify my software, and then that's the big issue. So we will see how to counter that in the next slides. As well, a typical error. Please come back. Another typical error is to consider the DO-178 and its rigor as a compartmented activities. That's usually a big mistake as well. And for example, usually the testing process is not thought ahead and is not thought when the design phase is starting. That's definitely another roadblock in order to meet your certification, and we will see how again we can counter that issue. As well, cycles of deliveries. Usually, clients are taking too long before different versions of the software, and basically releasing late a software version, you discover and you raise a lot of issues on the testing side, and that's definitely an issue can compromise your milestones, but as well the cost of your certification. Related to that, the fourth point related to the testing starts too late. That's as well a typical issue that we faced with customers, and unfortunately, discovering errors after having done all the development, there's definitely a cost to that, because you have to redo all your activities to fix these bugs, and you have to redo the whole process from the CM, from the development side, the traceability activities as mentioned by Matt. So typically, the cost of fixing a bug goes exponential. And the last thing I would like to emphasize is everybody's facing the question about in-house or outsourcing, but taking the bad supplier or taking the wrong organization definitely has an impact again on the quality of your software and on the deliverables and on the steps of your certification. And that's why today there's a lot of myth around the DO-178, and especially regarding the cost. And usually the DO-178C is so as, oh my God, I don't have this money to spend on the DO-178. And there are ways to counter that. So if you go to the next slide. So let's talk about how to organize and how to develop and test and certify this software. Usually, one of the roadblocks that we see from OEMs and tier ones are, how can I protect my IP? And my answer to that, as a supplier like CS, usually we have the infrastructure to protect your IP. We are working already with big OEMs. We comply with regulations in terms of security of the infrastructure, protection of the data. So definitely, this is a concern that that should be removed in this specific case. Of course, it depends on how the development of the software is part of the value of your company. Do you want to retain these talents and this expertise, or are you choosing selecting a supplier to do that? One word on the offshore. Nothing against the offshore, but again, you need to be very cautious about implying right away an offshore company. If you have a short project, that's definitely, per experience, that will be definitely a hard road to take. We have an offshore entity, but it takes really years to set up the infrastructure so that we have something mature and in place by involving these entities. I just want to highlight as well, be careful about the export control, because you have to comply with this with the EAR regulations, especially if it is a commercial aviation. So we have this expertise as well to be sure that we can export outside the US if it is a path that you are taking. Next slide, please. All right, so you didn't plan for the certification, and again, you may be in that position that you have something, but you don't know why. And one thing that we suggest to people is to perform a gap analysis. So this gap analysis will give you the right picture on where you are at a certain point of time. Are you lacking traceability? Are you missing software artifacts? Do you have plans in place? Is there updates to be done? So a gap analysis is usually a non-expensive way to ensure and to go back on the right path of the certification. And usually it's a few kilo dollars to perform this deep analysis on the samples of the data that you have. Definitely to plan for a certification, I wouldn't emphasize enough on the fact that doing a benchmark, that's really a thing that to be done ahead of the curve. Because depending on the characteristics and the features of your software, depending on the product line that you have, depending on the length of your program, depending on the viabilities of your system, a benchmark will establish the right tools and the right processes, and definitely you will save a lot of money and there's a lot of effort along the certification steps. You go to the next slide, please. So the cycles of delivery is too long. Definitely the time to market, understanding the status and the maturity of your software is super important. And usually people think that because of the DO-178 and because this is a more waterfall type of process, we have to do things step by stage. But there are now some methodologies based on Agile, where you can basically define very recurrent deliveries, and again understand early on in your process and in your development and in your testing the maturity of your software. Usually this is what we do here. We do some what we call sprints in order to deliver frequently the software and again identify this maturity. And this is as well a way to monitor the performance of the team, and usually as well to improve the competency of the people on the projects. And that's as well as the main benefit as well to have a better estimate of the cost of your software development and testing. Next slide, please. And that's the last guidance I would like to bring on the table. The first thing is we are really the advocate, and this is in the vein of doing a benchmark. Do prototypes, do a round trip as well to test that the software, the testing is done in the right way. Convince your DER that we have already the infrastructure to do a qualitative software. I wouldn't emphasize enough on the second point as well. Work upfront the strategy of testing when you do the architecture of your software. We find ways with some customers by being involved upfront to gain up to 30% of the cost by just establishing the right tools and the right methodology to test. So very important to do these kind of things, and that's joining basically the prototyping thing. The testing, I wouldn't emphasize enough as well on the fact that we have to use high-level type of testing. System testing usually are the most representative way of doing the activities, and to detect the real bugs. And related as well to the rigor of the DO-178, usually people think that the different steps of testing must be basically segregated. And we developed some techniques to combine this kind of testing and to ensure again that we find the real bugs early on, and that we reduce the cost by combining again this and reduce the burden of the low-level type of testing activity. So it's very important again to plan for this for these things, because if you do that too late in the process, definitely it will be difficult really to recover. And one last message I would like to convey here is regarding the automated tools and the automation today. We are in an industry where I would say the convention is to use a lot of engineers and to have a manual work and to have the eyes of the engineer just to check about the compliance and be sure that the data is good, etc. Unfortunately, this is a thing that we will put behind because of the pressure on the industry, pressure to reduce the cost. And today, we, as mentioned in the beginning of this presentation, we invested massively in software tools in order that we test the embedded software. And now we are exploring techniques like the machine learning and artificial intelligence in order to be better, to be more consistent, to be cheaper, and to be quicker. And that's definitely a trend that the company embraced, and that will be definitely the future and the competitive advantage that we try to put on the marketplace. So that's conclude our presentation. Dave, I don't know if you want to take over from there.
Yes, we have a few questions that have come in. The first was, is CS Group SEI level 4 or 5 certified?
I can start to answer to that question. We are not. We equivalent to, let's say, a CMMI 2 or 3, but we never went to a formal certification. And why? This is because the CMMI brings a structure which is an overkill structure for us. And again, going back to the agile methodologies, in opposition maybe sometimes to what we think the rigor of the standard, yeah, but that doesn't bring more value. And again, in a world where we have to be more efficient, the CMMI structure doesn't, as analyzed by the company, is not the right way to go. We have some other certifications. We have the AS9100D, which is the common quality standard that we have to apply for aerospace products. But going on over the 9100 and going to the CMMI doesn't bring value, and I would say reduce the value to our customers who require more flexibility and more quickness to be faster, etc. And again, CMMI doesn't bring that kind of value.
Just to add to that, however, we do a lot of things that CMMI level 4 and 5 call out. You know, I do believe we are a solid CMMI level 3 company, although we have not been officially audited. We definitely do metrics collections. We watch for statistical process control with our testing activities to ensure that we are meeting targets in both cost and schedule, as well as quality levels. So we are very proactive in identifying issues and then identifying even future issues as we go through. So we do kind of incorporate some of the best features of CMMI 4 and CMMI 5 levels.
Thank you. Here's a question. Do you anticipate model-based code generation will overtake hand coding for most software development, and how will that change your business going forward?
So I guess I'll start. Yeah, I do think that model-based code generation is becoming much more of a factor going forward. It definitely does provide a lot of nice benefits associated with it. You know, certainly the models allow early sandbox playing with it. However, I do feel that for very specific applications, interfacing specifically with hardware pieces, or for very time-centric calculations, when you start getting in some of the high-speed signal analysis, those kinds of things, that we will have to still have hand-coded optimized code. It's just the nature of the beast. The automated code generation tends to not be as lean and mean as somebody who can go through and hand code it, and that's where we would see the differences. So I do see model-based code generation going much further than it has, but I don't see hand coding going away ever in the near future.
Okay.
And a quick compliment as well is we are already in the model-based activities. We have this expertise regarding the new standard. I would say if we are again prototyping and doing a benchmark with this kind of tools and the adequation to your product, to your software, that's where we can help to understand, are they valuable to your project? And you have to consider that these tools are pretty expensive. So we can help you to compute the return on investment on these kind of tools and see, yeah, are they valuable? Do you see a gain? Yes or no? And that's definitely the kind of thing we can help as well.
Thank you. Next question is, can you give some examples of aircraft programs you've assisted in certifying, especially any vertical flight systems?
So unfortunately, I'm not able to unveil any kind of projects or customers. Unfortunately, we don't have this room of this magnitude to do that. The only thing I would like to mention is we can definitely support. We supported vertical flight type of systems, but I would say whatever it is a vertical flight type of system, whatever it is an aircraft, whatever it is an automotive, I would say usually the ground rules are exactly the same. The software is a software. The system intent is different, but usually this is not. It's not, again, whatever the system it is. It doesn't change really the dynamic. It's really about the type of product that you have, and again, the intent of the software that you will develop. It will be applied to one system, multiple systems. What is the viability of these systems? That's really the main questions that we need to ask at the beginning of the project.
So if I can, let me ask the question a little more generically. And so for argument's sake, for a layperson, could you give an example of a type of system, what that system does, and how it integrates into the aircraft? Is that a question that doesn't go beyond your NDAs?
No, that's fine. Maybe you can provide this.
Sure. So we've been involved in lots of different systems, but specifically a couple that come to mind. One is the engine control systems. Certainly,
Okay.
The engine controls are a critical portion for vertical flight, and so it would interface directly with the air data systems in the vehicle, as well as the pilot interfaces. The collective, the PLA, those kinds of things, so that it would be able to apply the correct power to the rotor system in order to maintain or do whatever maneuvers are requested. Another system that we have been involved with is display systems, certainly, that we've been working with display systems, again, providing the pilot with data consolidation as well as indications as to what's going on, so that they can see that information coming from not only the data system in there, but various sources, including the engine applications. So all that gets interfaced onto the glass cockpit.
Thank you. So maybe you've answered this, maybe not, but our particular publication is focused on eVTOLs and hybrid VTOLs, with the approximately 300 or so concepts, if you will, that are in development. Again, without giving away any proprietary information, are you assisting in any of those? And can you tell us in a general or generic way what you're doing?
So, I'll go ahead.
No, go ahead, Jerome.
So, definitely, we are not per se assisting right now companies doing this kind of concepts. Flying taxis, electrical aircrafts. One of the trends we saw is, and this is related to one of my slides, where people try to retain the IP and doesn't want to unveil it a bit what does their system, and they are reluctant to outsource or to share a little bit where they are. And again, this presentation was a little bit to reassure them about using suppliers like CS. But definitely, we know that a lot of people, as you mentioned big numbers, right? They will face without no doubt this kind of certification. Just want to mention as well that we are part of the oh my God, SC240, which is the subcommittee from the created from the RTCA and EUROCAE to define the new standards for drones. That's something that will come as well. Drones are flying today thanks to waivers from the FAA. So we are working on this new standard that will be applied for these specific types of flying vehicles. So we are at the beginning of the curve. There are today not a lot of concepts that are close to the certification. There are maybe 4 or 5. But as you said, a lot of people are behind, and then our job is really to help us to plan for their future certification.
Exactly.
Thank you. Feel free to toot your own horn here. Can you tell me the key differentiators for the type of or the quality and types of software that you develop versus perhaps some of your competitors?
So definitely, we are very versatile in the different tools that you mentioned. We are able to work with all the COTS tool standards. You mentioned model-based. Someone asked the question. We work with all these tools, so we have already the expertise and the competency. We have, of course, the experience about hundreds of certifications with our customers about the 20 years. But I would say again, where we try to put the main differentiator is reducing the cost for our clients. So we are doing a lot of R&D and a lot of we design new tools to be more competitive and to be to basically lighter the burden of the certification for our customers. So this is definitely where we want to compete. And to be honest with you, where we try to compete as well is with the offshore companies. We want to be cheaper than these companies. So that's definitely the vision of the company, and that's the trend that we embrace, and we are investing massively today to make that happen.
Thank you.
Yeah, I just like to add that one of the things that we strive for, in addition to being the right solution, is the right processes. That we tend to want to be a partner as opposed to just a supplier. And by that I mean we want to go in and not necessarily come heavy-handed about these are the way you have to do things, but work within a company's processes to make it work within things like DO 178 and all the other standards to really adapt and work with the company. Sure, there's shortcomings that would have to be addressed, but by and large to be able to fit in with that processes as opposed to coming in with new processes. Another discriminator is we tend to think big picture down. And what I mean by that is even from our testing philosophies of testing at the highest possible level and gaining credit at the lowest possible level. We see, as you've mentioned, as well as Jerome, that there's a lot of model-based tools out there that are being used, and that use is going up substantially. Well, with that use comes automatic code generation. So the use of manual humans, engineers developing code has gone down a lot, and the code generation tools are very good. So we don't see a lot of errors, and the code's not what it's supposed to be. What we do see errors in is the integration of different software modules together, functioning properly, as well as meeting the overall intent of the system. So through the processes, we've moved testing up to the highest possible level, ensuring we get coverage at lower levels. but able to reduce costs, reduce schedule along those lines to, again, help get the client's time to market down, to be able to get that software out there in the field operational.
Thanks. So you've kind of now just touched on my next question, which is, what do you see as the next level, if you will, of development in avionics software?
I think, I'm going to go against what I just said about hand coded. I think that there's a lot of innovations in processors. I hate to admit, back in the old days when I was doing it, but memory and timing were very constrained. The processors were very slow, so it became an issue. And that's really where the hand coding had to come in. You had to jump around in different pieces of software to make it all kind of fit. Well, memory devices are much higher density. Processors are faster. Multiple core processors is definitely something that's being used now and will be used more effectively in the future. So that the model-based engineering really is going to come into very mainstream usage as opposed to just parts of it, because the hardware now has the throughput to manage non-optimized code at that point, for lack of a better word, that comes out of the model-based generation. So there'll be less and less hand coding, more of model, machine coding from these models. So that's where a lot of these tools are going to be migrating to, and being able to do the analysis on the models themselves as it goes forward.
Thank you. I don't have any other questions. I don't see any other questions in the queue. And we're coming up on the time you've offered to share with us today. So if there's nothing else from anyone, perhaps I'll pass it back to you, Jim, for a final wrap-up.
Great. Thank you, Dave. And thank you, Matthew and Jerome. That was a great presentation. From my background, it all sounds very familiar from the days when I worked on engine controls back in probably not one of your current companies in your suite of customers. So thank you so much for spending the time today. I do want to remind our audience that there is a brochure that CS provided for us in the handout section of your dashboard. Give you a little more background on what CS capabilities are, and perhaps you will find that of value. And we'll reach out to either Jerome or Matthew and continue. So with that, we are at the top of the hour, and so we thank you for joining us today, and we look forward to seeing you participating more often in the future. So thanks again, and thanks, Dave, for a great job moderating.
My pleasure. Thank you.
And we'll see you all down the road.
Nice meeting you, gentlemen. Thank you very much for your time.
Thank you.
Thank you.